Hi, and welcome to Mr. Garofalo's podcast. In today's episode, we are looking at example 5 from Average Rate of Change classwork. In this example, we're told that Frances is selling glasses of lemonade. The function g of t equals t squared plus 4 divided by 2 models the number of glasses she has sold, g, after t hours. What is the average rate at which she is selling lemonade between t equals 2 and t equals 6 hours? Include proper units in your answer. So my suggestion when we encounter a problem like this is to create a t-chart. Our input is hours, we use t, and our output will be g of t, glasses sold. And I also want to find the interval over which they want us to find the average rate of change. Time 2 and time at 6. So we're going to take these inputs, plug them into the rule, and get an output. This would be 2 squared plus 4 would be 8. So after 2 hours, she sold 8 glasses of lemonade. And 6 squared plus 4, which is 40. So after 6 hours, she sold 40 glasses of lemonade. So to find the average rate at which she is selling them, we really want to know how many, on average, is she selling per hour. And that's really what our calculation is all about here. So I need to find the change in the output values. It looks like she sold 32 glasses of lemonade over a 4-hour period. So we're going to make a ratio. Change in glasses sold over change in hours. And we would find that the average rate of change is 8. So on average, she's selling 8 glasses of lemonade per hour. What's interesting about a function like this is that that rate is not constant. So if we put in 3, 4, and 5 for values of t, what we would find is that we don't simply add 8 glasses on each time. See this squared here? This is indicative of something called a quadratic function, which we have yet to study. But we can apply rate of change principles to it. So let's see what the rate of change is when we put in these other values for t. So 3 would be 3 squared plus 4, which would be 13. 4 squared plus 4, which would be 20. And 5 squared plus 4, which would be 29. So let's examine what's happening here. From 2 to 3 hours, she sold 5. From 3 to 4 hours, she sold 7. From 4 to 5 hours, she sold 9. And from 5 to 6 hours, she sold 11. So notice how the rates of change, which I'll highlight here, notice how these rates of change are different as we increase from 1 hour to the next. But our calculation calculates the average rate of change. So if we take those 4 increases, 5, 7, 9, and 11, we would find that their sum is equal to 32. And if we wanted to find the average of them, since there are 4 values, we divide by 4. And we get 8. And that was our calculation over here. So average rate of change. can be applied to functions that are linear. You can also apply it to the functions that don't have a constant rate of change. Slope principles are applied here. 8 glasses per hour is the answer to this problem. Hopefully this is helpful. I would suggest making a t-chart if you're stuck, or actually making a t-chart just in general for each of these problems I think is very helpful. See you in class.